Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of limits. And if I talk about the question which is given to us here from this topic, the question tells us to find the value of a limit where x tends to pi over 2, and the function that is given to us here is the denominator is given x minus pi over 2 the whole square. The numerator is limits of integrals from x cube to pi over 2 cube, and the function given to us is sine of 2 t raised to 1 over 3 plus cos of t raised to 1 over 3 dt. So we get this entire function, and the question is asking me to find out the value of this limit. And if I talk about the answer choices that we have here, the options are 3 over 2 pi square. The second answer choice we have is 9 over 8 pi square. Third answer choice we have here is 5 over 9 pi square. And the last answer choice we have here is 11 over 10 pi square. So we need to figure out which one of the answer choices is the correct answer for this question that is given to us here. Let's see how to solve this further. Before starting off with the solution for this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos, and it's also free for you but also motivates me to put up better content and try to make the solutions as easy as possible. So let's do the question further. So if I see the question first, and if I substitute the value of the limit x as pi over 2 in the numerator and the denominator. So if I see the denominator first, it becomes pi over 2 minus pi over 2, which is 0, and 0 squared is 0. So your denominator turns 0. Whereas if I solve for the integral, if I find the function's integral and then if I put my limits, the lower limit is pi over 2, the upper limit is also same. So when your upper limit and lower limit both are same, if I do the subtraction of them, it gives you 0 form again. So you get 0 by 0 form again, and once you get that, you understand that you need to apply the L'Hopital's rule. So if I apply my L'Hopital's rule here, so using L'Hopital's rule, if I use the idea, I know whenever there's 0 by 0 form, I can find the separate derivatives of both numerator and the denominator and then apply the limit to that. So limit x tends to pi over 2 as it is. And when I have L'Hopital's rule applied, I find the derivative of this integral, which goes from x cube to pi over 2 cube. Expression is sine of 2 t raised to 1 over 3 plus cos of t raised to 1 over 3 dt. And further, if I find the derivative of the denominator also, it is x minus pi over 2 the whole square. So you get the derivative of this entire expression. Let's see. So if I want to find the derivative of the integral of a function, for this first, let's do it. So using my Newton's Leibniz theorem, I'll try to find the derivative of the integral of that function first. And whatever we get it, we will substitute that here. So let's try to do that first. So if I have to find the derivative of an integral where you have the lower limit and upper limit as this, and if I want to find, let's say, integral of a function d of x, what I do here is put f of g of x. So you put the function of the upper limit into derivative of the upper limit, minus you put the function of the lower limit into derivative of the lower limit. So you get this. So let's do this here also. So if I do that here, this derivative is applied to integral with the two functions. So I'll take both of them separately. So if I do it for the first part of the function, f of the upper limit, so it becomes sine of 2 pi over 2 cubed raised to 1 over 3 into derivative of that. So derivative of the function that is upper limit becomes derivative of pi over 2 cube, which is a constant. So it becomes 0 basically, minus function of the lower limit. So it becomes sine of 2 x cube raised to 1 over 3 into derivative of that as well. So that is 3x squared plus. If I do that same for the cos function, it gives you cos of t raised to 1 over 3, so it becomes pi over 2 cubed raised to 1 over 3 into derivative of pi over 2 cube, which is basically 0, minus this, if I see, cos of x cube raised to 1 over 3 into derivative of x cube, which is again 3x squared. So you get this entire thing. Now further, if I try to solve this expression, I get this turning out to become 0 minus derivative of this basically becomes x cube in raised to 1 over 3 is basically x. So you get sine of 2x into 3x square. So you get here sine 2x into 3x square. Further, if I see, I get minus, this becomes basically 0 again. So plus 0 and minus, so let's write this plus 0 minus this basically becomes cos of x cube raised to 1 over 3, which is cos x, and 3x square again. So you get 3x square times cos x divided by, so this is the entire numerator. And if I find the derivative of this entire expression in the denominator, it is nothing but derivative of, let's say, x squared. So function, when it is squared, we get the derivative, that is 2x. So 2 into x minus pi over 2. And since I treated this entire function as x, I have to find the derivative of that, which is basically 1. So I get this, and we are applying limit of x tends to pi over 2 to this entire function. Now, once you have this, let's see. So limit x tends to pi over 2, you get minus 3x squared common sine 2x plus cos x divided by 2 x minus pi over. Now, once I have this, if I put my value of the limits here, let's check what you get. So if I put it here, pi over 2 minus pi over 2, which is again 0. And if I put it here, I get minus 3 pi over 2 the whole square. Sine 2 into pi over 2, which is sine pi is 0. Cos into pi over 2, which is also 0. So you get this also turning to become 0. So you have a 0 by 0 form. And once you have a 0 by 0 form here, further, if I try to solve this, let's see what do I get. So what I will do is here I have this 0 by 0 form. So again, I will apply the L'Hopital's rule. But first, let's try to simplify this as much as we can. So minus 3x squared into sine 2x minus 3x squared into cos x divided by, you get from here 2x minus pi. So now if I apply my L'Hopital's rule here, because it's 0 by 0 form, I just simplified that. So if I apply my L'Hopital rule, I can find the derivative of both numerator and denominator separately. So if I do that, I'll write this limit extends to pi over 2 as it is. And if I apply the derivative of this, first let's find the derivative of denominator. So it gives you 2 into derivative of x, which is 1, and this is 0. So you get 2 here for the denominator. Numerator, if I see, it's basically your u into v rule. So minus 3, I'll put it out. So x square into sine 2x will become x square into sine 2x derivative is cos 2x into 2 plus, if I put sine 2x as it is and derivative of x square, which is 2x. So 2x sine 2x minus 3 again out, x square into cos x. So cos x basically becomes derivative, that is minus sine x plus cos x, derivative of x square is 2x. So what you get here is limit x tends to pi over 2. 2 in the denominator gives you minus 3x square and 2. So minus 6x square cos 2x minus 6x sine 2x minus 3x square, so plus 3x square sine x and minus 6x cos x. So we get this entire thing. Now if I apply my lower limit and my limit here where x tends to pi over 2, let's do that. So if I apply that, I get minus 6 pi over 2 square cos of 2 into pi over 2, which is cos pi, minus 6 pi over 2 sine pi plus 3 pi over 2 square sine pi over 2 minus 6 pi over 2 cos pi over 2. The whole thing is divided by. So we get this. Now further, if I apply the ideas, I know cos 0 is 1, cos pi over 2 is 0, cos pi is -1. So you get this is -1. So -1 into -6 becomes 6. And pi over 2 the whole square becomes pi square over 4. This sine pi, if I do it, sine 0 is 0, sine pi over 2 is 1, and sine pi is again 0. So this entire thing becomes 0. So this term gets vanished. Sine pi over 2 is again 1, so plus 3 and pi square over 4. Minus this cos pi over 2. So cos 0 is 1, cos 90 is again 0. So this also turns 0. So you get this and divide this whole thing with 2. So what you get here is 6 pi square plus 3 pi square, 9 pi square over 4. The whole thing divided by 8. So you get 9 pi square divided by 8. So we have this entire thing, and if you see the answer choice that matches here with the question, it is option B. So B becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of using Newton's Leibniz theorem. So that is basically derivative of an integral of a function. Whenever you don't want to find it, you just do the function of the upper limit into derivative of the upper limit minus the function of the lower limit to the derivative of lower limit. So that will give you the derivative of an integral of a function. And once you get that, then you have to just apply the L'Hopital's rule until you do not get 0 by 0 form. And then once you apply the limit, you got the answer 9 pi square over 8, which basically matches with answer choice B. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of the questions on JEE so they can also take the benefit from this. Thank you.